Okay, today we're going to talk about what laws govern motion. So, learning target 16, be able to apply Newton's first, second, and third laws, give examples, tell the difference from diagrams, pictures, and or descriptions. Okay, so Newton's first law of motion has three parts. Newton's first law of motion says that an object remains at rest unless an unbalanced force acts upon it. So it will not move unless we have some unbalanced forces. An object will remain at rest if the net force is zero. Remember, if net force is zero, forces in opposite directions are the same, so we subtract and that will get us zero. Object remains in motion unless a balanced force acts upon it. So an object's going to continue moving unless the forces equal each other in opposite directions, and then it'll stop moving. So I thought this was pretty funny. A body at rest tends to stay in rest. Stay at rest. A body in motion tends to stay in motion. I thought that was kind of cute. Okay, so this little animation right here, remember we were talking about how speed kills? Well, there's a reason why you should be wearing seatbelts, because an object in motion stays in motion unless a balanced force acts upon it. So the brick wall is acting upon the car, not the person. So the person is going to keep moving because nothing has stopped the person. The person's in the car, moving forward. Nothing stops the person from moving. So that's why seatbelts are so important, because seatbelts will be the force that stop your motion in a car accident. You don't want to have, well, you don't want to see what's happening to this guy happen to you. So that's why you should always wear seatbelts. Newton's first law of motion. Okay, Newton's second law. An object acted upon by a force will accelerate in the direction of the force applied. So that makes sense. You kick the ball, a soccer ball, it's going to go in the direction of the force that you applied with your foot. The way we calculate Newton's second law is force equals mass times acceleration, and it's measured in kilograms times meters per second squared, because remember acceleration is meters per second squared. 1 kilogram times meters per second squared is equal to 1 Newton. So that's why the force, or I'm sorry, that's why the units for force is Newton, after Sir Isaac Newton, the scientist who discovered these three laws. The more force, the more acceleration. That makes sense. Okay. One thing that Sir Isaac Newton made sure that he explained is that he wanted to make sure that gravity was probably one of the most important forces that we have. It's always going to exist between any two objects that have mass. We've talked about this before. If you increase the distance between matter, it decreases gravity. Increase the mass of matter, you're going to increase the force of gravity. That's why Jupiter, the largest planet in our solar system, has the most mass. It also has the greatest force of gravity, except for our sun. Our sun contains 99% of the mass in our solar system. Only 1% was left over for the planets. So our sun has the most force of gravity, and that's why all our planets orbit around the sun. So I thought this was pretty cute with the force of gravity. That's why I only study under cherry trees, because gravity will pull an apple down, hit you on the head, knocks that guy out. But that's pretty cute. Gravity is not just a good idea, it's law. That's Sir Isaac Newton. Okay, and let's come back to weight. Weight is a force. Remember, force equals mass times acceleration. And when we calculate weight, it's mass times acceleration due to gravity. So here on Earth, mass times 9.8 meters per second squared. Weight can change if gravity changes, like in space. Mass cannot. So I thought this was pretty cute. I don't know what to do. The more I run, the more weight I seem to put on, because he's getting more mass as he rolls down the hill. Just once I'd like someone to congratulate me on losing some weight instead of accusing me of getting smaller. Unfortunate world of the fast food body image. Okay, the last thing I wanted to show you is talking about the forced air resistance. So remember we talked about air resistance has to do with surface area. So the more mass that's located on the surface, the more surface area. So if you take the example between the elephant, and it looks like, I'm not sure what that's A is. It could be a penny or something small. But it has more of the mass located on the surface than the elephant. So with air resistance being greater on A, okay, that's why the elephant will hit the floor first before object A, because it has less air resistance, so the force of gravity pulls. Now, if you put these two objects where there's no air resistance in a vacuum, then the elephant and object A are going to hit the ground at the same time. Okay, hopefully that gives you a good idea of what Newton's first and second law is. We will have another video on Newton's third law.